Question 8 is a modeling function using some facts about area. And the first thing they want you to do is show that the area of the rectangle can be written as that. And so this is a show that question, which means you have to start off with an equation and do algebra to come up with their answer. And we're working on the fact that area is length times width, multiplying the two dimensions. And so we just have to, this is kind of going back, FOIL, multiplying out the brackets, and then simplifying our work. And that's the algebra that we need to do. It's a 1 point question, so basically they're thinking you should be able to do this fairly quick and easy. And we just have to simplify, and we have shown that the area is indeed what they say it is, 35 plus 4x minus 4x squared. Part B. They want you to fill in the values of the table and calculate the values of P, Q, R, S. So I need to put the equation into my calculator, and then I can look up the values on the table and just write down what those values for P, Q, R, and S are. We're now ready for part 2, which they want you to graph, and they've given you a scale to use for the X and Y axis. And so I've drawn that out and drawn it to the scale. They tell me that on the A axis, so I'm actually going to label the Y axis A, and that we're using 1 centimeter for 5 values. I've plotted the points based on the table, and this is a parabola, so I know even though those two lines are straight across, it should be a bit of a curve. And this should be, again, a freehand sketch and not just connecting dot to dot. As this is a parabola, one of the things I do know is that it has an axis of symmetry. It should be right in between those 2 points, 0 and 1. So I sort of know that there's an axis of symmetry going all the way down, and that should be at about 0.5. And that leads me right into part C, where it says using your graph or otherwise. We'll come back to this or otherwise idea. But using the graph, write down the equation for the axis of symmetry, and I just pointed that out, that it's there at 0.5. And that's one way of using my graph to determine that. Remember, it's an equation, so I need to have an equal sign in there, and it is x equals 0.5. Part 2, they want me to find the value of x for the rectangle whose area is 27 meters. And this goes back to the fact that my y-axis is the area. So I can go up to 27 meters and just draw a line going across, and then look at what the x values are. And for this problem, it happens that those values were part of my table even. And so I can see there that x equals 2 is one place where the area is 27. Using that value of x, write down the dimensions. So I go back up to what they gave me and substitute for x, and calculate out that it is going to be 9 and 3, and that makes sense. Again, just sort of checking my work and the fact that 9 times 3 is 27, confirming kind of that I'm doing things right. And now part D. On the same graph, draw the line of the equation a equals 5x plus 30. That's a straight line, y equals mx plus c. And so you can see I've already sort of plotted those points. So I start at 30, the y-intercept, and the slope is 5, which is going over 1 up 5. And because of my scale, that just makes it look like I'm going over 1 up 1, but really, I'm going to the left, I can go down 5 and over 1, down 5 over 1. Applying the points, and I connect them up, and there's my line y, or a equals 30 plus 5x. And then part 2, they want me to, again, answer hence or otherwise solve this equation. That word hence is a clue that you should be able to use work that you just completed to solve this equation. But 4x squared minus 5x, or plus x minus 5, where did that come from? Well, it comes from the fact that they did some algebra. So let me just show you where it came from. If I set those two equations together, and sorry I kind of flipped around, 30 plus 5x instead of 5x plus 30, it's the same thing. And essentially their equation equals 0, so I need to move everything from the right to the left. And so I'm going to add 4x squared, subtract 4x, and I will subtract 35. And that will make the right side all equal to 0. And then I simplify and come up with the left side. So I now have 4x squared. I subtract 4x from 5x, and that gives me plus x. And subtracting 35 from 30 gives me that minus 5. And again, I've canceled everything on the right side, which is making it equal to 0. And so the hence, using what I've already done, what they've really asked me to do is find out where do these two equations, the 30 plus 5x and the quadratic 35 plus 4x minus 4x squared, where do those intersect? Where are they equal to each other? And so we have 1 point and somewhere down there. Now that first point looks pretty obvious, but what I'm going to do is go to my calculator to make sure that I have it exact. So I have the two equations in my calculator, draw the graph, and I'm going to calculate the intersection. And just remembering that the steps for calculating the intersection are second calc, or second trace, and the intersection. Here we just have to move the cursor over close to where the first intersection is, take a guess, and it tells me that the intersection is when x equals 1. The y value being 35, we don't necessarily need to know because we're just solving for x. And so I now know that one value of x is equal to 1. And again, that was pretty clear from my graph. The second equation, or the second intersection, isn't so clear. If my graph was perfect and I was accurate, I could probably take a good guess, but again, use my calculator to be exact. And just need to move the cursor over, and calculator tells me that it's at negative 1.25. So there are the two answers solving this equation. Now, I want to talk about this otherwise idea, because when you see otherwise, basically the IB's saying do it however you want. And what they say, solve the equation, 4x squared plus x minus 5. So another approach I could do is literally solve that equation. So I'm just going to type it into my calculator. And I want it to equal 0. And I'm not going to graph 0, but I'm going to look at the table. And there I can see one place where the equation equals 0 is at 1. That confirms what I knew. The other spot doesn't show up on my table. So I'm now going to draw the graph, and from there, I'm going to have my calculator calculate the 0. And here again, I'll do the quick shortcut. The left bound, I know -2. I don't have to look past -2. And now the right bound, I can set it equal to 0. And the guess, I'm just going to kind of move the cursor over a little bit and hit enter. And again, I find -1.25. Simply, this is a second way because they again have told me otherwise I can solve this equation. And so I've just decided to solve the equation they gave me. I get the same results.